Well, hello everyone. It's past, so we're going to start the second session in the workshop we're having today on online job vacancy data. So welcome to everyone if you've just arrived. My name's Arthur Turrell. I'm a senior research economist at the Bank of England. I'm going to be chairing this session. We've got some really good talks in the session. Really, they revolve around the idea of job vacancy data for the public good. And I think that's a really important topic. And, I think there are huge potential policy benefits of using data on labour market demand for its granularity and its timeliness to better understand what's going on in the wider economy. And certainly at the Bank of England, we've worked with Indeed to do that, and it's been really useful throughout this crisis. So I just want to remind everyone that this session is being recorded, and also to please submit your questions through the Q&A option at the bottom. We've info on the session and who the question is for. Now, we've only got 10 minutes per presenter, so we're going to leave all of the questions to the end, and you'll be unmuted to ask your questions. Just a reminder to the presenters, strict time limit of 10 minutes to present. And on that, we'll go over to our first presenter, Cath Sleeman from Nesta. Cath.
Thanks so much, Arthur. Can you hear me all right?
I can, yeah.
Brilliant. Okay, thanks. Well, thanks so much for having me. As I said, I'm Cath Sleeman and I'm a data scientist at Nesta. And today I wanted to talk to you about two projects. One that we're just starting called the Open Jobs Observatory, and another that we've just published called Mapping Career Causeways. Next slide, thanks. So just in case you haven't heard of us, Nesta is an independent charity and we're focused on innovation. I sit within Nesta's data science team. There are about 20 of us in the team now, and we focus on showing how novel data and machine learning can be used to address, or at least improve our understanding of some of the big challenges that we're facing as a society. So from the likes of an aging population to automation. Next slide, thanks. So within the data science team, there's a small group of us who focus on improving labour market information. And the reason we do that is we see the uncertainty that different groups face as they navigate the labour market. So, for example, we know that workers find it difficult to know what other jobs are they skilled for. And then, of course, adding to that uncertainty at the moment is the fact that the labour market is experiencing a lot of disruption, not just from the sudden shock of COVID, but we've also got those more gradual sources of disruption like automation and climate change. So that's why we're in this space, to try and improve labour market information. Next slide, thanks. So the main project that I wanted to speak about today and to get your thoughts on is called Open Jobs Observatory. And the primary aim of the project is to scrape job adverts just from a small number of job boards, and only with their permission, and then build an observatory or repository that contains insights about skill demands from analysing those adverts. And crucially, we want to make those insights kind of open and accessible to all. The secondary aim of the project is to begin to create an open code base for cleaning, processing and analysing job adverts. And again, we want it to be something that others can use and hopefully kind of add on and improve. And this project is, I should say, is jointly funded by Nesta, but also the Department for Education. Next slide, thanks. In terms of why we're doing this, this project, the main reason is that, as you all know, and others have spoken about, job adverts are such a rich source of information. We've been using them at Nesta for about 4 or 5 years now. And I think in addition to the kind of usual benefits that are spoken about, there are two key strengths for me. The first is that they're free text, so we're not forcing employers to choose skills from a list. That enables us to detect kind of new skills and new jobs. I think the greatest strength of adverts is that they enable us to link together different pieces of labour market information. They provide that crucial link between skills and jobs, jobs and salaries, salaries and locations, etc. And so we can really use them to enrich the kind of official labour market information that's available. Next slide, thanks. So there are 3 phases to the project. The first is to collect adverts directly from job boards, and we're currently in the process of reaching out and gaining permission. We already have a couple on board. We'll only have 4 for the minimum viable product in this kind of first phase of the project. We are trying to reach out to monster jobs at the moment, so if anyone did have a contact there, would really appreciate it. The second phase of the project involves cleaning adverts and then extracting insights from them. And as I said, would really like to kind of work towards building some common standards for processing adverts. And so we'll be publishing our code that we develop for that. And then the third phase of the project is sharing insights with others like yourselves. So the project only runs until June next year, but we'll be looking for a small amount of funding after that so that we can keep it going, keep the collection going, because we think that the value of the data set will kind of grow over time. Next slide. So there are 3 types of kind of outputs that we'd like to publish. The first is a set of job profiles. So for the most commonly requested jobs, we'd like to kind of profile the kind of typical skills that you need for those jobs, an estimate of the salary range that the jobs pay, and perhaps some indication of the typical qualification levels of these jobs. We'd also then like to publish a weekly stock of kind of vacancies, but broken down by a few more variables than the official data typically is. So we'd like to break it down by broad occupation groups, so SOC, SIC for industries, regions as well, and then also broad skill groups too, ideally. And then finally, we'd like to publish some indicators on what skills are growing most quickly and also most slowly, and do the same thing for vacancies for different broad occupation groups. So that's the plan at this point. And then just finally, next slide, thanks. Finally, on the kind of, we're just starting to really identify the methodology that we're going to use for kind of extracting the different bits of information that we're after. We'll start with deduplication, kind of between sites and within sites as well. We'll then assign occupations. So we'll assign 4-digit SOC codes using the ONS's coding index. Ideally, though, we'd also like to assign job adverts to ESCoE, not this ESCoE, the European Skills, Competencies and Occupations ESCoE. We'd like to assign industries. We've previously matched company names to company's house and extracted zip codes using that method. So I think we'll try that to begin with. Step 4, calculating weights, is all about adjusting our stock so that when we break it down by industry, by first digit SIC, it matches the ONS's official breakdown to kind of correct for kind of biases and ensure that our data set is representative. The key step for us is step 5, extracting skills. We'll start, we think, with NZ's list of open skills. And then use NLP to see whether we can extract kind of variations on those words. And then lastly, we've got salaries and locations. The tricky thing with salaries is that we'll be converting different pay rates and trying to do that in a sensible way to get a kind of annual salary. And then for locations, we were just planning to be really cautious and only publish data at NUTS 1 level, but we heard from several people that LEPs would be more helpful. So we'll see, we'll just have to see how we go with that. And that's the project. So that's the first project, Open Jobs Observatory. And then if we go to the next slide. So in the last couple of minutes, I just wanted to mention a new project that we've just published a couple of weeks ago. And it's called Mapping Career Causeways. So if we go to the next slide. So for this project, we've measured the similarity between just over 1,600 different occupations. And similarity is based on the skills and work activities required in each role. And so this map shows the kind of the map of similarities, if you like. So each dot is an occupation, and the more closely 2 dots are to each other, the more similar we think those jobs are. And we've done this using ESCoE, the European skills framework. So we've taken their occupations, that's the 1,600 occupations, and we've used the skills that they mention, but then we also wanted to bring in information on work activities. So we did that by creating a crosswalk between ESCoE and ONET so that we could bring in information on work activities. We've also just published that crosswalk between ONET and ESCoE, and that's available on our GitHub page if anyone would like to use it, and also ideally improve on it too. So broadly speaking, there are 3 use cases for the map. The first is we want to try and support job transitions by identifying what we call the viable and desirable transitions that people can make from their current job. So if someone works in one occupation, we can tell them at least a range of other occupations that are quite similar to their current role based on the skills and work activities required. We'd also like to be able to provide skill recommendations. So what we can do is, if someone knows the occupation that they want to move to, we can say, well, given your current occupation, here are the skills that you will have, here are the skills that you may have, and here are the skills that you may not have and may need training in. If someone doesn't know where they want to go, but they know they want to undertake training, then what we can do is, oh, thanks very much. We can say is, based on your current job, here are the skills that would most expand your set of viable transitions. So here's the skill that would be most beneficial for you to learn. And then lastly, we can hopefully provide something for policymakers by showing workers, by identifying workers who are at risk because perhaps they have isolated occupations, isolated skill sets. And also we can overlay other things on the map. So perhaps we just skip the next slide because that's a video that doesn't play, unfortunately, but it's on our website, and it just shows, it considers the case of a shop assistant who's looking to change jobs and kind of shows what their options are and kind of explains why the viable transitions are viable, etc. If we just go to the last, the use case 3, thanks. So what we can do is we can overlay automation risk onto the map, and we can show that those whose jobs are at high risk of automation also typically surrounded by other jobs that are at high risk of automation, because those jobs that require similar skills tend to have similar levels of automation risk. And so that's why we think some workers may need a little bit more help to try and escape automation risk and to move into lower risk areas. And to do that, they'll need to undertake more retraining. So over the next year, we're looking to trial the algorithm and existing tools. We're keen to work with others to run experiments and to test whether providing this information does actually change people's search behaviour and cause them to kind of look in new types of jobs or new types of upskilling. But I will leave it there because I'm out of time. But thank you very much for listening.
Thanks, Cath. That was really interesting. Just a reminder, put your questions in the Q&A box, and we'll address questions to all of the presenters at the end of the session. So next up, we've got David Rosenfeld from BEIS, the Department for Business, Energy and Industrial Strategy, who's going to be talking about how they've been using online job vacancy data over the last year, I think. Thanks, David.
Hi, thanks, Arthur. So I'm David Rosenfeld. I'm a data scientist in the Advanced Analytics team of the Department for Business, Energy and Industrial Strategy. And this presentation is just going to show some examples of how we use online job vacancy data in the government department. Next slide, please. So the background is that we first started using this data about 2 years ago for a pilot project, but we've been making quite intensive use of the data since March 2020, at the start of the first lockdown, and we use burning glass data at the moment. And so this presentation is going to be a bit of a whistle-stop tour of how we can use this data, and it's going to be more breadth than depth, but hopefully it can show some interesting examples of what can be done with this type of data. So the first example is going to be showing how we use the data to monitor labour markets during the COVID-19 pandemic. The second one is looking at a more experimental use of how we can use this to possibly look at the impact of some government interventions. And the third one is on tracking innovation diffusion. Next slide, please. So first example, monitoring the economy since lockdown. Next slide. So BEIS uses a range of real-time indicators to monitor the economy that are collected by the advanced analytics team. and online vacancies data is one of those. And as many of the other presenters have said, it offers not just the ability to look at things in real time, but it also offers a lot of extra detail that other data sets don't necessarily offer us. Next slide, please. So jumping straight into the results, the chart I'm showing here, the black line is the year 2020, and this shows from January to sort of November, I think. And the red line shows the 2014 to 2019 average, and the pink ribbon shows the range over that period. And this is a rolling average. We use this visualization because, as other presenters have said, this is quite a seasonal data set. It's also relatively volatile. So it's useful to compare to previous years. And we can see that there was quite a big drop in March and April 2020, but there's been a progressive recovery in vacancy numbers. And unlike what Indeed was reporting via Pavel, actually this data set suggests that the job vacancy numbers returned to more of a historically normal level by late September, early October. So it's quite interesting to see that different data sets show slightly different conclusions. And we haven't seen such a big dip in the second lockdown. Next slide, please. However, despite the recovery in overall numbers of job vacancies, we saw quite a big change in composition. The top chart shows healthcare and social work vacancies, and you can see that these have been really above historic average for much of this year, while the chart below shows that vacancies in accommodation and food services have not only dropped severely, but have not recovered anywhere close to a historic average. Next slide, please. And another very interesting aspect that we found is obviously the increase in working from home options. So Burning Glass has a variable that allows to track which vacancies allow working from home, and we found that that has really jumped from around just over 2% up to March to over 6%, in October. Now, whether this is a lasting change, it'll be interesting to monitor over the next year, as hopefully restrictions get eased, and see to what extent it's a lasting change, but it's certainly very interesting for us. Next slide, please. So I'm going to jump to the next example, which is looking at the impact of government interventions. So this is a very experimental piece of work, and the example I'm using here is Hinkley Point C. Next slide, please. The background to that is we were curious to see whether we could use that kind of data for sort of monitoring and evaluation purposes, and we tried to just experiment with an example with Hinkley Point and see whether Burning Glass could show anything about the kind of jobs that are created relating to Hinkley Point. And so what we did was just look for job vacancies that mention Hinkley Point in the job text. It's a very simple rule, and just see what we could find. Now, this is a purely experimental piece of work, and to note that this isn't actually used for monitoring and evaluation at the moment. Next slide, please. So what we found was that there's a noticeable jump in the share of job vacancies mentioning Hinkley Point after the government approved the project of Hinkley Point C in September 2016. Next slide, please. And the really interesting thing is to look at the kind of skills that these jobs require. So what we show here is not so much the top skills that are required. What we look at here are the most different skills that these jobs require compared to average UK vacancies. So because the most frequent skills are usually very common, but that way we really focus on the skills that differentiate these vacancies from others. So unsurprisingly, the most different skills here are linked to nuclear energy, they're linked to engineering and procurement, and these are, it makes sense that a lot of the vacancies we find here have these skills. Next slide, please. But the really interesting thing as well is that we can look at a lot more detail within that. So we looked at 3 areas where there was a fair bit of job creation, and looked at how different the skills were demanded in these particular areas compared to other areas of the UK within burning glass vacancies, within Hinkley Point vacancies. And we found that in Somerset, the top skills that were relatively more demanded were around civil engineering and sort of organization and implementation. But also, very interestingly, we found that food preparation, food service experience, and cooking were in relatively higher demand than elsewhere. And that might be evidence of sort of indirect job creation of that project. Looking at Bristol, the middle chart, we found that the relatively higher skill that was required was French. It doesn't mean that French is very highly required for these vacancies, but it's relative. So if it's not in high demand in the UK as a whole, it'll really show up here. And it might be that because the project is run partly by EDF Energy, there's a need for some people to liaise with the French company. But otherwise in Bristol, we found that there was quite relatively high demand for engineering design skills. And in London on the right, interestingly, the relatively different skills were linked to sort of leadership, building effective relationships, and some sort of back office skills like accounting. So hopefully that gives you a bit of a flavor of the kind of thing that could be done, looking at big projects and the kind of jobs that they create. Next slide, please. And finally, I'm just going to very briefly talk about innovation diffusion, which is our original project that we did 2 years ago. Next slide, please. The background for that is that the UK was found in 2018 to rank highly in terms of innovation, but less well in terms of knowledge diffusion. And so we wanted to see whether burning glass could shed light on the adoption of technologies in labour markets. And a consultancy called Faculty did a pilot project for us. We had 2 approaches. First of all, just look for a list of keywords of interest linked to technologies. And secondly, a more organic approach where we looked at which keywords grew the most over the period we considered. Next slide, please. This shows some of the results. We find that...
1 minute, David.
Thanks. We found that AI grew fast between 2012 and 2017 as a share of all vacancies, but plateaued since. Cloud computing related skills grew between 2014 and 2017 in particular, plateaued before and after, while additive manufacturing, which covers the 3D printing related skills, grew throughout the period apart from a short plateau in 2016. Next slide, please. We can look at it by sector as well. And we found that professional, scientific and technical services, for example, were the first sector to adopt AI in terms of high speed of growth in adoption, which is relatively relatively unsurprising. But we can look at it really by sector. We could also look at it by occupation and other cuts of data, but that's really the strength of this data, is the amount of detail we can go into. And next slide, please. I just wanted to close with a bit of an odd but interesting example where we looked at deep learning. So in red, you see the points and the line, the smoothing line, are the job vacancies that require the skill deep learning. And in blue, what we did was we tried to benchmark those findings using another data set. And what we used was data from the GitHub API. And what we did was to look at repositories where the README file included the string deep learning and whose owners were registered in the UK. when looking on the GitHub API, and the sort of the dates here, the dates that the repository was created. And those two data sets seem to suggest some consistency in that they suggest that there was a big rise in deep learning between 2016 and 2019, and maybe that's slowed down and very slightly dipped since 2019. And so it's quite an interesting case where we tried to check our findings from Burning Glass using a different data set. And next slide. And that's it for me. Thank you very much.
Thanks very much, David. That was a real whirlwind tour, and very, very interesting. So next up, we've got Khloe Evans from the ONS, who's going to tell us about using online job advert data to inform human capital and labour demands. Over to you, Khloe.
Thanks, Arthur. So hi everyone, my name's Khloe Evans, and today I'm presenting on behalf of the team at ONS who've been working in collaboration with King's College London to understand how we can use online job advert data to inform. Next slide, please. So in terms of an agenda today, I'll be talking through the way that we currently use our online job advert data within ONS, and I'll touch a little bit on some of the methods that we've implemented. I'll then discuss the work that we've been doing with King's College London to construct an initial algorithm which can extract skills from job advert data. And then finally, I'm just going to close the presentation by talking a little bit about the overall aims that ONS has for online job advert data and how we think that we can add value in this space. Next slide, please. So I imagine a lot of you on this call are already aware that we started producing an experimental job advert series on a weekly basis back in May. So we've had a few iterations of these data, which I think reflect some of the challenges in understanding how best to present these series. So initially we produced a version of total job adverts and job adverts split by the categories defined in the Adzuna data, which were indexed to the 2019 average. And the main reason for using an index series is because we're aware that there are some issues of duplication in the online job advert data. So we want to display the information in a way which focused on the change in trends over time, as opposed to the actual levels of job adverts. We then introduced a job advert series split by NUTS level 1 regions in August. We first began by displaying this information as the horizontal bar chart that you can see in this middle of this slide. So when we first included this data in the release, we wanted to have a focus on the pandemic impacts. So in this chart, the green bars represent the change from the lockdown minimum to the latest value of that week. So kind of highlighting the recovery that the different regions had made. And the red bars showed the percentage change from the 2019 average to the lockdown minimum. So kind of highlighting the drop in job adverts across the different regions. And then the white dots just showed the overall change since March 2020. So the data was displayed in that way for a couple of weeks, but then we converted it to a time series to allow our users to analyze the trends over time for the different regions. And then most recently, a few weeks ago, we have changed the time series to show the percentage of the level 1 year ago, as opposed to being indexed to the 2019 average. As again, this was something that our users said they would find useful in terms of interpreting the results. Next slide, please. So prior to publishing the data, we did undertake quality assurance of the Adzuna data by comparing with other sources such as the ONS Vacancy survey. So although the two sources do cover quite different things, as job adverts don't relate directly to vacancies, it's still a useful comparison that can give an indication of quality. And as you can see from the chart on the left-hand side of this slide, the orange line there is the weekly experimental Adzuna data, and the blue squares is the ONS monthly vacancy survey. And we can see that the trends in the Adzuna data are fairly comparable to the vacancy survey, certainly at this high level of all industries. There is, however, less comparability in some of the individual categories. So the health and social care, which is on the right-hand side, is one that generally maps better to the Adzuna data, but you can see there is still some divergence in some of the trends. So this validation was really important for us, as our focus within ONS is all about producing a clear and consistent picture for users as to what the fundamental trends in the data are showing. So from our perspective, regardless of the source or even the sources that are being used, we need to ensure that there's consistent messaging for our users. Next slide, please. And this need for consistency also follows through into the specific methodologies that are being applied. So as part of our development work, we've spent a lot of time considering different methods for allocating job adverts to locations, for example. And what's come across quite clearly is that the different methods that we have implemented will have different impacts on the end results in terms of the time series that you achieve. So on this slide, I've included the steps for location matching that we've developed. Important to highlight here that the text that's in italics is not currently the method that we're using in terms of what we publish. So this is some additional development work we've done recently. And the text that are in normal font is consistent with what we have published on our website at the moment. So as well as our current existing methodology, which involved extracting postcodes and matching them to regions and doing some text matching of locations, and then finally applying some manual corrections, we've added in a few additional steps. So the first one being an initial manual assignment of locations. And what that does is it targets the most frequently occurring locations. And we quickly saw in the data that 2,500 locations actually cover 80% of all the job adverts that we have. So as this seemed a fairly manageable amount for us, we in the team manually coded each one to a local authority and its subsequent NUTS level 1 region. And we've also added in some cleaning steps to the lookup files that we're using. So some of the issues that we were having is there's a lot of common location names whereby lower level geographies such as wards might have the same name as a local authority. Or there are also instances where wards can have identical names, and that was causing issues for us in our text matching. So I think the key takeaway for us in doing this work was that the different methods that you use will give different results. And so it kind of highlighted the importance to us for consistency. So if we go to the next slide, please. So whilst looking at extracting locations, another realization for us was the importance of duplication, which can impact on the series as well. So deduplication mainly occurs in the data when there are multiple adverts for the same post, and that can be caused by the same advert being posted at different location levels, or it may be that the same advert is posted by a different job company and they use slightly different text in their descriptions, which can mean they appear as separate adverts. Alternatively to this, you can also have an underrepresentation, as some job adverts can be singular but cover multiple posts. So in terms of addressing this issue, we at the beginning started to consider very complex methods, so looking at things like cosine distance measures and a number of different algorithms. And we found that these were very computationally expensive for us. So we then considered some much simpler methods which just involve some basic data cleaning, and found that these basic steps, such as removing white space or the last sentence of an advert, can result in the identification of a lot of the duplicates. A key thing for us is because we're publishing at the moment on a weekly cycle, so we extracted Adzuna data on a Friday and then publish the series the following Thursday. We really need to take a process which has optimal processing time. Next slide, please. And the final part of methodology that I'm going to discuss today is around skills extraction. So we're still in the early stages of this work, but we've been working with our colleagues in King's College London, who have developed an initial algorithm that it can be used to extract skills. And the approach that that algorithm has taken is to use a word-to-vec model, which is a natural language processing technique that uses a neural network model to learn word associations from text extracts. So the model uses a skill list which has been extracted from dice.com, which had over 11,000 unique skills. And then for each of these skills, descriptions were taken from Wikipedia to provide a little bit more context into what the skill sort of entails. And the results that are on this slide at the moment are based on extracts of Adzuna data that were taken in May and then again in September. So we've been able to capture the change over time. And the chart on the left shows the average number of skills per advert. So you can see that's relatively low for most job adverts, having around 4 skills per advert. But there are some outliers in the data. So there's some job adverts which were having up to almost 40 skills. And when we investigated some of these series cases, they related to jobs in the IT sector. So there will be roles such as software developers, which required knowledge of many different programming languages and software packages. But it also is, thanks,
Sorry.
that's okay. But it's important to note that this could also be due to introducing some bias based on the list of skills that we're using. So DICE has a lot of IT skills included on it. So that again, highlights the importance of consistency. And then on the right, we can see the most popular skills asked for in the education sector. So we can see tutoring has become more popular since May, whereas most other subject-specific skills have remained fairly consistent. So that's just some early results, and we're still refining that algorithm, but we wanted to share those with you. So next slide, please. So hopefully that's provided a useful overview of what the ONS have been doing in this space. So I wanted to close this presentation just by highlighting some of the future aims from our perspective. So firstly, it's clear, Firstly, it's clear to us that we need a consistent view across the GSS of vacancies and skill demand. So online job advert data will have some bias and some coverage issues that we're already aware of. So for example, that we know that some types of jobs, such as in the IT sector, may be overrepresented online. And we know that there are still some jobs that are advertised in window panes or by word of mouth that will have coverage issues on online data sources. So I think it's important that we have a common understanding of these biases and coverage issues. And equally, we want to make sure that our messaging to users is consistent, because ultimately that will lead to consistent decision making. We also want there to be coherent methodologies applied across the GSS. So regardless of the data source that we're each individually using, we think the methodology can be applied in a consistent way. And one of the things that has become apparent to us whilst we've been developing our methods is there are many different techniques that you can use for this kind of work to extract information, things like locations, occupations, skills, and requirements for the job. So I think we need to move towards some level of consistency in what each of us are doing. And we do think that ONS can create a coordination role across government and across our organisations to try and facilitate that. So that's our thinking on the topic right now. We're very much evolving, so happy to take on any feedback that others may have. So please do get in touch with us, and I'll pass back to Arthur. Thank you.
Thanks very much. That's a really exciting agenda that you set out there for the future. Excited to see that come to fruition. So our next talk is The Human Capital Behind AI by Leah Samek from the OECD. Leah, do you want to take over?
Yes, thank you very much. So in today's presentation, I will provide a very, very brief summary of some of the completed, but also some of the ongoing work of our team. And here we use burning glass technology data to try to investigate the human capital behind AI. Next slide, please. Thank you. So first, my colleagues, Mariagrazia Squicciarini and Emile Cammeraat, who are also here today, and you will hear Mariagrazia later on in the panel. They both looked at the statistical representativeness of BGT, and I will present some of the highlights of their paper in the next slide. Then Mariagrazia, together with Heike Nachtigall, investigated the kind of jobs that demand AI-related competencies, They looked at firms, they also looked at industries that post these kind of AI-related jobs. And now our team tries to build on this existing work by characterizing the cognitive, but also some of the non-cognitive skills and particular skill bundles, so how these kind of skills are interrelated in these kind of AI-related jobs. We also want to define these types of jobs by distinguishing here between core and non-core AI-related jobs. And here the idea is really to get a good idea of who are the AI developers, so basically who is advancing AI, who are AI adopters. And so once we've done this, then we can characterize these AI developers and AI adopters a bit more carefully. Next slide, please. Thank you. So let me show you the highlights of the representativeness study. The main verdict is basically that the statistical representativeness at the occupation level is good, but it does vary over time. And this is also because the coverage of the data has increased over time, and it does vary by occupation. So some of the occupational groups, in particular managers and professionals, for example, are much better represented in the data compared to some of the other occupational groups. And this other group was mainly focused around the low-skilled occupations, so workers in agriculture, forestry, fishery, and so on. Having said that, the big advantage of BGT is that it can actually be linked to other occupation and industry data. And this is because it already classifies the job openings following international taxonomy. So we have SOC and SIG codes in there. If you, however, want to generalize these results, so for instance, to inform policy, then it's actually very much advisable to use weights that have been constructed in this paper in order to get a more balanced representation of all of the occupational categories. And having said that, for the kind of work that we are doing right now and the results that I'm going to show you, we basically, and I think we can all agree on that, think that, you know, AI really lives in a digital space. And therefore we are quite confident that actually all the job postings that we are particularly interested in are posted online and therefore are covered in the data set. And so for the ongoing work, we actually refrain from using these kind of weights. Next slide, please. So I think, you know, I had a quick look at the list of audience, and I think some of you already attended the ESCoE conference where Mariagrazia kind of explained in more detail of, you know, how we define AI-related jobs. But I want to just quickly refresh your memory, especially for some of the new people joining this work strand. So we identify AI-related vacancies using a list of AI-related keywords, and they have been based on Barufaldi's work. But then this list has also been extended to also include software and repositories. And here, a big thanks to our colleagues from BEIS who validated this list. So we follow a quite conservative approach here because we then consider job postings to be really AI-related if the ad contains at least 2 AI-related skills. So having simply artificial intelligence in there is not sufficient. And then on top of that, these AI-related skills have to belong to different concepts or different methodologies. And I think it's easiest to explain this based on an example. So if you have a job advert which contains the word neural networks and convolutional neural networks, for instance, then we say that these 2 keywords belong to the same concept, and therefore this job ad would not be considered AI related. If it now also contains, let's say, the skill computer vision, then we would consider it because these are coming, or computer vision is coming from a different kind of concept. The next question is, how many people do we actually talk about? So how many people are working these kind of jobs or are demanded in these jobs? Who is really advancing AI? Who's developing AI? And so on the left-hand side here, you can see a diagram which shows the share of AI-related jobs in overall BGT job postings over time. And so you can see that between 2012 and 2018, there's been a clear upward trend for the countries that we show here, which are Canada, Singapore, the UK, and the US. And you can see a particular spike for Singapore. But at most, 1% of all the jobs in BGT are AI related according to our definition. Next slide, please. So since this workshop is organized by ESCoE and BEIS, I thought it's quite interesting to zoom in a little bit more and see where exactly in the UK these kind of jobs are actually located, or these vacancies are located. And so it seems that they are actually clustered in only a relatively few areas, with half of them being in London, which I guess is not a big surprise. Many of them are also kind of in the surrounding areas of London. So you see a lot of them in Cambridge and in Oxford. And then over time, so if you compare the map in 2013 to 2019, we can see that a lot of these clusters have been emerging, have been growing. So for instance, if you look at Scotland in more detail, you can see just a few of these yellow spots, which then turn darker and turn orange. So for instance, if you look at Edinburgh or Glasgow, so this is indicating that, we have more AI-related jobs here. You can see a similar trend happening in Birmingham and Manchester, just to name a few. Next slide, please. So the next question we really asked ourselves was, do these workers work together with AI, or do they really advance AI? And so here in these four little charts, you can see the frequency with which these AI-related keywords appear in our AI-related defined jobs for the years 2012, which is the kind of black bar, then in 2015, which is the dark gray bar, and then 2016, which is the light gray bar. And so basically you see that over time, the kind of lighter gray bars are much higher than the darker ones, implying that we have many more AI-related jobs in here. But very interestingly, we also see that over time, there's a growing number of AI jobs that actually require multiple AI skills. So they basically seem to become more AI intensive. And so part of this result is because we can see a huge increase in the demand for specific software related skills. Next slide, please. We've also started looking into some of the employers. And so here you can see the number of skills, but not only AI related skills. So here all skills required by Amazon, Facebook, Google, Microsoft, and Apple. And we try to include the subsidiaries here as much as we can. And so you can see that, around 80 skills are commonly demanded by all of these 5 companies. But at the same time, you can see that, for instance, for Amazon, almost 270 skills are really only uniquely found in Amazon's vacancies. So this raises the question if employers really require such different skill sets, which, might well be, because in these AI jobs, as I was saying earlier, some of them are looking for these kind of core AI developers that are really advancing in AI. Others might be looking more for AI adopters. But it could also be a simple explanation of different wording used in these different vacancies by these employers. It could be also a combination of both. And so we try to look into this right now. And next slide, please.
Just 1 minute left, Leah.
Thank you. And so we carried out a network analysis here, which shows how AI-related skills in these AI-related jobs are linked. And we're using the US as an example. And so you can see that a lot of the skill bundles really seem to be interrelated, with the neural network being in the center. So we highlighted this in yellow here. And now the next slide, please. But you can also see that we have some really kind of core AI development bundles in blue that really relate to advancing AI itself. Then at the same time, you see some this kind of orange bundle, which we call AI applications, because it tends, so the skills in there tend to relate more to speech recognition, image processing, and so on. Then you can see a gray circle, which is kind of highlighting the robotics related skills. And then another one in green, which we call the more support functions, basically. Next slide, please. And so the next and final question was, okay, so how are these AI skills linked to non-cognitive skills? And so what we've done here is we looked at the 50 most frequently demanded skills in the US again. And you can see that, a lot of these skills tend to be, let's so-called, more general. They are often relating to rather tools of the job. So we have, R and SAS in there. And next slide, please. And this is then also confirmed by the fact that, we see Python and SQL that are really in the center. So again, here highlighted in yellow. At the same time, in the kind of purple circle, you see a lot of the non-cognitive skills that seem to be in high demand, which I guess, it's not really surprising, and they are complementary to these more core AI related skills. And examples here are communication skills, problem solving, teamwork, and so on. So now the final slide, please. So this was really a very, very quick overview of the kind of work that our team has been doing so far. You can see here a list of some of the ongoing work. So, the to-do list is still very long. We still have plenty of more ideas that we want to incorporate using the BGT data set. But now I'm happy to start the discussion and happy to answer any questions and welcome any comments you might have. Thank you.
Thank you so much for that, Leah. That was really interesting. I particularly enjoyed the network diagrams. In fact, I very often see network diagrams and don't think they're very informative, but those ones I found genuinely really useful. Okay, so we're going to move on to the questions now. So I just want to first thank all of the presenters for a set of really interesting talks, showing how we can use this kind of data to better inform policy making. We've got some questions in the chat. Do put your own in. And I think the first one we'll take is for Cath from Dominic Blatt. Now I understand we're going to unmute Dominic. Is that right? I think
yeah, right.
There we go. Okay, Dominic, go ahead.
Thank you to Cath. Yes, I have a question about the intermediary vacancies. How do you deal with them when weighting vacancies to fit the ONS statistics? I'm asking because they are difficult typically to deduplicate and difficult to assign to industry.
Yeah, it's a fantastic question. I was just reading it before. So, and if anyone has the answer, then I'm all ears. I can tell you what our approach will be to kind of assign industry codes to those types of adverts. So, as a first step, we'll look to the company name that's being advertised, and we'll try and match that within company's house and try and extract a SIT code that way. Though I think the IDBR, ideally, if you can get access to that, has a kind of broader coverage or better kind of coverage of SIT codes than company's house itself. If we're not able to locate the company, then we'll look for keywords within the name of the company and potentially within the advert description itself. If we can't do that, then I think what we'll look to do is to create this mapping between SOC codes and SIT codes. So infer a SIT code from the SOC code. And to do that, we'll use the last census, which has that mapping between SOC and SIT. And then worst case scenario, I guess we don't assign the advert and it gets dropped from our data set. That's the plan as it stands. Thanks.
Okay, brilliant, thanks. So the next one is for David from Oleksii.
Thank you, Arthur. So my question to David is related to two charts that David showed about AI jobs and cloud jobs, and I was really fascinated and surprised by the results. It seems these two trends overlay to a great extent. So the question is, do you agree that these almost identical trends prove the point that most of AI jobs are growing on top of cloud infrastructures, which had risen since 2017 cloud invasions in the UK by Google, Azure, and Microsoft, and so on? And that's why it's kind of, you can have some causal relationship that cloud technologies arise and on top of them AI demand increased.
Thanks, that's a really interesting question. I wouldn't go as far to claim that these two charts would prove anything, of course, but I think it makes sense that these are two very linked technologies, and that I think it's understood that a large amount of the growth in AI is partly due to the improvement in computational capacity. So I think it makes a lot of sense. I think probably more work would need to do to really prove that, especially from burning glass data. But I'm sure that that's very interesting work to investigate.
And I'll just add to that, you might be interested in the work by Diane Coyle, which has shown a huge fall in the cost of cloud computing, which may also be driving that trend. So we've got a question from Raymond for Lee.
Hi, Lee, can you hear me?
Yeah, go ahead.
Hi, yeah, I found your press really interesting, and like Arthur, I like the chart. I'm wondering about COVID-19. Have you seen anything about remoteness and AI jobs? So one of the things I've read in a few blogs and things is COVID-19 could reduce migration flows. So I'll give you the example of Ireland. A lot of our immigration is very skilled workers, including in AI, but mostly tech, to come to Ireland to work to fill very skilled jobs. Now that these jobs maybe can be done more remotely, you know, what might this do to migration flows? Have you any thoughts about that? It's a very forward-looking question. I know it's not exactly what you were talking about, but I wonder, has it come up in your group?
Yeah, thank you for the question. So basically the AI work in itself, so far we've covered up to 2019. So we haven't looked into 2020 data yet, simply because it requires a lot of data cleaning, and the exercise is yeah, quite time consuming. But having said that, we can see that there's an increase in the demand of IT skills. So not, you know, AI skills in itself. But there is actually a very interesting paper from the ECO Directorate, and I can send this to you later on if you want. So yeah, something we definitely want to look at, but we haven't done as of yet.
Thanks, Leah. I'll send you an email. Thanks.
Thank you.
So I want to ensure an even distribution of questions to our presenters. So I'm going to jump in and use my chair's privilege to ask one to Khloe, and also kind of for Cath as well. What difficulties, you both talked about making some of this job data open to more people. So what difficulties and barriers do you face in doing that? What can be shared and what can't be shared? Khloe.
I can go first. So there's a number, I would say, of challenges, one of which being data providers themselves. Obviously, we can't forget that this is a commercial data source, and so they need to have arrangements with all of their users. So there is a limit on what we can provide. There's also a limit in terms of resources, I suppose. So I think for ONS to take a big collective lead in making these methods and data available, we will require extra resources to dedicate to that work. But we do know that there are a lot of users who are looking for it from that perspective. So it's something we are considering. I don't know if you want to add anything, Cath.
Yeah, so for the Open Jobs Observatory, we can't release the underlying kind of raw job adverts. We've promised not to do that. So we can only release the kind of insights or aggregated data. I think the kind of greatest challenge there is communicating the uncertainty around the estimates and ensuring that people have an understanding of kind of just particularly variables like salary, the huge ranges that you see if only, you know, 60% of job adverts mention a salary. And the kind of, I think the challenge is there in the kind of a communication one. I guess with the other data sets we've used that we've purchased from job providers, the kind of restrictions vary. In some cases, we haven't been allowed to publish all the skills that are mentioned in the job ads, so we've only been able to show examples. And yeah, again, we've never been able to, you know, release the underlying data, which is kind of, you know, which is what you'd expect, I guess. Yeah.
Yeah. Okay. Thanks. Thanks for taking that. Do keep putting your questions into the Q&A box. Next up, we're going to have Mary from ESCoE and King's College London.
So I have a question for David about his Hinkley Point data, which I think was really fascinating. So it appears that the jobs, arguably good quality services jobs, are staying in London with these big projects. And I was wondering to what extent you could look over time to see if some of those type of jobs move. And then what's the scope for rolling out this further? I mean, it seems to me this is a fascinating data that could be really useful for looking at the regional divide and the extent to which firms move with these big projects. So I was thinking possibly HS2, but there must be other projects that you could look at. So what are there plans to go further on this?
Thanks, Mary. That's I'm glad you found it interesting. Yes, we are looking into other projects to apply it to. We don't have any very firm plans at the minute, but you know, likely candidates also probably going to be around sort of industrial strategy objectives, particularly around green growth, clean jobs, things like that. But the example of Crossrail is a really good one, and that's something we should look into. We've had so much demand from across the department really for using online vacancy data that I think that we have more ideas than capacity at the moment for using this data, and that's partly what's been constraining us, I'd say. But that's something we want to pursue. So, you know, I'd gladly continue that conversation with you offline if you are interested in working with us some more on that.
Yes, because, you know, we have the new Productivity Institute, and we're really interested in that regional divide. So a way to do get in contact. I think there's something really interesting there.
Yeah, thank you.
Lee, we've got a question for you about AI skills that I'm also really interested in, because I've done some work on AI skills and labour demand too, from Oleksii. Oleksii, we can't hear you at the moment.
Sorry, do you hear me now?
Yes.
Okay, thank you. Thank you, Arthur. So, Leah, my question to you is, obviously you showed us different skills that you're exploring and considering that go around AI skills. So my question is, how broadly do you define AI skills? Do you include DevOps skills or data engineering skills, data analysis, data cleansing and visualization skills as well into your AI skills definition? So where is the boundary of AI and non-AI skills, which would be other technologically related skills, but not AI?
Yeah, so that's a very good question, and you're not the first one asking this question. So basically, we have the kind of examples that you mentioned. Yes, they are within the keyword list, but there are skills like Python, for instance, you know, where it's very arguably a tool which is used by, you know, economists as well, for instance, and you know, we are maybe AI adopters, but not AI developers. So there has been a lot of discussion going on whether we should include these things or not. BEIS was actually also very much involved here in validating the kind of skills that we then decided to be AI related or not. But at the same time, this is why we also then add another layer. So we're not only looking at these skills and basically say, okay, let's say, you know, because R is mentioned in there, it's an AI, or Python, it's an AI skill or not. We try always to combine this together with another skill that also has to be AI related, so that we have at least these two skills in order to identify a job to be AI related. And again, these two skills have to also come from two different concepts. So what I mentioned during the presentation. This way we might kind of underestimate the amount of identified AI skills, but we think it's better to be cautious rather than to include, you know, a lot of jobs in there that are basically requiring, asking for tasks that are not really about AI.
Okay, so for example, if there would be Pandas skills, which is skill working with tables, and Python skills, do you consider these jobs as AI or not?
No, sorry, the first one was, sorry, I didn't hear it.
For example, pandas, it's kind of framework inside of Python, which is also broadly used, but different.
Yeah.
Or there are some SQL, for example, SQL and Python skills. Do these two skills would probably define AI?
No, they wouldn't, because we assume that they are within the same concept.
Okay. I see.
So it would need to have another one, which, like computer vision, for instance. If this would be within the job advert together with, Python or some other ones, then yes, but otherwise, no.
Thank you so much.
That makes sense to me as well. I'd say most AI jobs require Python, but most Python jobs don't require AI. So it kind of makes sense.
Exactly. Yeah.
We just want to say a quick thank you to Gueorguie for pointing out an initiative that Cath might be interested in by the IAB called the Job Futuromat. So Cath's going to check that out. Thank you. Just to note on timing, we've actually got till 35 past. We were granted extra time. I don't know why, but let's enjoy it because we've still got some questions to go. So next up, Sanjeev had a question, I think, for everyone. Is that right, Sanjeev? You're on mute. I tell you what, Sanjeev, I'll just ask the question for you and see if you can get yourself unmuted. So Sanjeev asks, so AI posts and vacancies in the UK seem to plateau in the charts around 2016, 2017. Any reason why? Who haven't we heard from in a while? Khloe, maybe you want to, could you take that one?
I can say that I'm not sure. For the time series that we have with the Adzuna is 2018 onwards, so that's kind of been the focus of our analysis. And the vacancy survey obviously would cover the 2016-17 data, but it's not my area, so I'd have to take that one away, I'm afraid.
David?
I think we're also not entirely sure. The thing to note is obviously that it's plateauing as a share of vacancies. When you look at it in terms of numbers, it's not necessarily plateauing as much. And the other thing is that might mask some trends within AI. So some particular ones are plateauing or decreasing because in terms of new vacancies, that's sort of maybe the labor market up to a point gets I'm going to say saturated, but you've had a catch up in terms of that technology, and now there still are vacancies. They're just not growing faster necessarily than other vacancies. But again, that might mask some particular trends within AI.
If I may intervene and propose my own hypothesis, which was connected to the previous question to David about cloud and AI. So I think it's not about plateauing, but it's just about spike or rise in demand for cloud and connected AI skills in 2016 and 17, where UK actually faced a big increase in the market for cloud technologies and AI technologies as well, because leading providers of cloud and AI platforms like Google, Amazon, Microsoft were invading the UK market. And that's basically where UK just had an opportunity to rise the share of these skills because there were technology available for people to jump in.
Thanks, Oleksii. Sadly, I think we're going to have to leave it there because it is 35 past now. We had a couple of questions we didn't get to, so I'm really sorry about that. Clearly, there's a lot to talk about here and a lot of shared experiences and kind of things to figure out. So particularly pleased to see that big program from the ONS and also from Cath as well about what's coming in the future. And hopefully I will see you in the sessions later today. So thanks all for attending, and a big round of applause to our presenters for giving such interest. That wasn't a very big round of applause, but a big round of applause to our presenters for presenting. Thank you.